Hello everyone, so this is Ash, and this is quite the unusual video. You see, a while ago I wanted to start doing reviews and actuality video because I often get myself dragged into news and technology. But I never stepped into that rabbit hole. Doesn't matter really, but I just wanted to share that because this would have been the kind of video I could have made. Anyway, let's get started with the subject for today, the Velocio ACE Mini PLC. I say mini because it's a tiny piece of hardware, but the commercial designation comes without it. Buying this was kind of a leap of faith really. I wasn't able to find many review or article. I suppose this is what you'd expect for a niche product that doesn't really interest that much people. Why, you might ask? Well, because there's plenty of alternative in the market, and they mostly appears to make more sense than this. So why on earth did I choose to get one? Well, we'll see that in a minute. First of all, let me introduce you the project I'm working on in the first place. I call this the water cooling washer, with my nickname embedded in the title, as if it was a misspelled word, but really it isn't. This project started a year ago, and on this channel you'll be able to see the other video I've made about it. Be aware they are in French. I'm doing this one in English to reach more people who could be interested knowing about these Velocio PLCs. Basically, this is a machine that can wash a pipe-based circuit. The so-called circuit can be whatever the heck you want, but the initial intent was of course PC water cooling. It relies on a fairly simple but effective principle. Have some cleaning liquid get hot enough and circulate inside a PC loop that requires maintenance. To do so, all you really need is a little tank, a heating element and a pump. But for the sake of it, let's throw at it some more stuff to add functionality such as reversing the flow direction, a second bucket with clean water, blowing some compressed air to dry it out, and finally, have the damn thing run on its own. Because we can. So after getting the hardware I needed, it was just a matter of assembling this prototype, then figuring out a way to easily control it. Last year I went for an Arduino. After all, I've used one on my previous project, the water case, and it has been great. But you see, me not being that much confident with written programming language, I knew that I wouldn't be able to pull it off on my own. Fortunately, I have a friend that can do that way better than me, and he was already behind the programming of the water case project. I'm mentioning all of that because it mattered to answer the why I did buy a PLC to replace the Arduino in the end. So the thing is, when you are working on a project with a friend that doesn't live near you and have his own personal life to manage, things get slowed down. Also, I felt kind of bad for asking him help on the time to program my Arduino. For this reason, I haven't done significant progress with the washer for an entire year. That's why I started to look for another way. Currently, you see, my living job is to work with PLCs. I'm an automation guy. That's also why I often struggle with written code. I do things in C the way I would have done it using ladder or SFC. Sure, it works, but it's a nightmare to read and debug. That's why I relied so often on my friend. He's doing such a good job at making things look neat and work great. During my journey, I stumbled across many things. First of all, the soapbox for Arduino. Yeah, why not stick with the Arduino if we can? It gives you a PLC-like programming environment, but comes with limitation, and doesn't really work for me, so next. I also found this flowchart-like programming software called Embryo. Looks neat, but I still find myself having to write C code in it. Though it looked like a really good piece of software that I'm keeping under my arm for the real-time parallel task environment it offers. Debug is a breeze. Then I considered switching to a more familiar hardware, PLC. I work with some Siemens S7 12000 in the past and really like the tire portal software, super easy and powerful. Dev time for me could be hours instead of days. But the cost. The PLC itself doesn't cost that much. I mean, it's reasonable considering what it can do, but the HMIs and the software licenses for it are in the thousands of euros. I'm not really ready to spend that much. It feels like a waste of money that I don't have anyway. Click's PLC from automationdirect.com seemed like a good option. Price is lower to similar than the Siemens one, but software is free and the HMIs are within acceptable price range. But I found it to be bulky in the end, and size is an important factor for me. Then, totally out of the blue, I stumbled across this Velocio PLC. What is that, I thought? Looks cheap AF and priced cheap AF, and no one seems to talk about it anywhere. That usually is not a good sign. I discovered later some Reddit topic about it, and one English video that mentioned some issue with it, one of which was the unprotected I/O. Well, in the end I thought that it wasn't much a problem, as the Arduino isn't protected either, and I never burned one so far. Throughout all the content I saw online, no deal breaker to be found really. Some people have used it and no problem to be reported. After downloading the free software for the PLC and the one for the HMI, I realized that my washer could totally be programmed with this and in a short amount of time. I immediately placed an order for mid-grade PLC with one 7-inch HMI. As bonus, these are Modbus devices, so they could be reused for other projects with Modbus hardware in the future. With one thermocouple, a serial link cable and a fiber power supply, my total is 430 euros. A bit pricey compared to my cheap current solution based on an Arduino Mega and a $70 Nextion HMI, but I'm not spending another year looking at my lifeless box waiting in a closet. So, the model I bought is an 18 direct output model, as I needed at least 14 of these, 6 direct inputs, 4 thermocouple inputs, and 3 analog 5V inputs. There also is a serial interface, RS232, for the comlink with the HMI, a power supply input, and a USB plug for the programming. The I/O ports have individual LED that indicate the status on or off. That's very handy to work with, as you can see if the program is working as intended without having to actually move any parts. This is a common feature on PLC, nothing new here, but if you come from the Arduino or Raspberry Pi world, you may not yet realize how handy this feature is. The outputs are syncing transistor type, meaning that every output pin is put to ground when activated through a 300 mA rated transistor. Basically, for anything else than an LED device, you want to pair each with a relay to avoid burning the transistor out. Inputs work quite identical with a pull-down resistor to ground, then you bring 3 to 30 volts into those and they lead up. Pretty straightforward. Now, onto the programming part of things. The software is simple in every way. I think the team behind it, or the guy who knows, aim toward the most efficient way to communicate with the user. It's not massively engineered software like Adobe or Siemens would do, but more like a small handcrafted software without much consideration for complex features. It feels functional, period. That being said, functional doesn't mean that it lacks in design or intuitiveness. On the contrary, I would say, let me show you what I mean. To initiate the communication with the PLC, all you have to do is create a project, click the Auto Setup button and let the software do the rest. all the I/O are automatically labeled for you and you can directly use them or rename if you want. I like this kind of approach, it really fits my way of doing things, no nonsense whatsoever. In a similar way, you don't have to think about the type and address of register you need to use for all your variables. Just place an object, enter a label and boom! Automatically use the correct register. If you try to use the wrong type, the software tells you immediately that something is wrong. I'm just seeing myself saving a heck lot of time with this kind of software compared to the free-to-do-everything of C programming. I totally understand why programmers don't like this, mainly for its inefficiency compared to structured code, but for someone like me who just wants the damn thing to work on the first trial, it's a godsend. In some way, it reminds me of the workflow I have with Siemens or Schneider, which is impressive considering this is free software. Well, you still have to buy the hardware, but at least there's no license package that you have to buy every now and then. After setting up the hardware, you are free to choose between two types of PLC programming, ladder logic and flowchart. Both work in a similar way, it's just really about presentation. I found flowchart to be useful in some situations, but I prefer to use ladder for the most basic but bulky task. Every important decision gate are present, so you are not missing on anything, and with a bit of thinking you can use the math block to create the one you could be missing if ever the case. About output blocks, every important function are present as well, even motion, which is a big thing for such a cheap PLC. You don't even have to program yourself the logic behind a stepper motor. Neat! For me, the most appealing block was the PID one, because I wanted to have temperature regulation and who knows what else in the future. If that's not enough, you can also add subroutines, not to be mistaken with programs that can be executed in parallel. This hardware is not capable of doing that, but more like embedded tasks that will be executed inside the main program when you call them. Of course, if you forget to add a return gate to your routine, then your PLC will be stuck inside forever. So you really have to think about subroutine as a way to present your program in a more digestible way. It is also possible to use subroutine as instances. For example, you want to have a little program that handles the opening and closing of a valve, and you have 7 valves. You don't want to just copy and paste 7 times the same bunch of lines, because if you have to fix a bug that affects all valves, then you have to repeat that change 7 times. You can, however, create one subroutine that you'll call 7 times, with the different input and output for each. Then, when you have to modify the behavior of the valve, just edit the subroutine and boom, you just modify 7 objects at the same time. It is basically the equivalent of C++ class and instances, I suppose. When it comes to communication with a Modbus device, things are also super easy to understand. Inside the Modbus window, on the left you have the binary table, and on the right, everything else. It is just easier to read than if every type of register were presented in the same list. The addresses are configurable for each line you add, of course, and presented in the same way that you would use in the HMI software. No bits conversion or thinking to do here. Earlier, I was saying that this software, vBuilder, felt like a handcrafted project, and so far I showed you functions that are worthy of paid one. Now, let's talk about the rest. For some reason, you cannot use Ctrl+C and V inside the register editor. However, right-click, copy-paste will work fine. No import-export function to set your list of registers in Excel, for example. The zoom function is welcome to have a bigger picture of your work, but the text size scales with the zoom, so everything gets quickly unreadable. Performance of navigating inside the Modbus window gets really bad and laggy increasingly with the amount of variables you decide to exchange. Weird. In debug mode, you can stop the cycle and go step by step, that's really good. But where is the option to force a value on the fly? Nowhere to be found. And the list goes on as you use this software. It also seems like the last update of the software goes back to 2016. The recent updates have been about adding support for the newer PLC model, not fixing bugs or adding functionalities. At least this is a stable software. I never experienced an unexpected crash so far. Now that's out of the way, let's talk about the Velocio HMI. What a weird piece of technology. If the Velocio's website gives you minimal information about it, then the actual unit gives you even less. No brand, no serial number, no datasheet, nothing. I have no idea of what kind of product this is. Some Chinese knockoff? The screen quality is the same as the Nextion I have. Not great, but not terrible. For the price, I'd say it's a good deal. 2 serial COM ports that support variety of protocol, USB in and out for printer or flash drive, and a supported 12 to 24 volt supply input. Though this wasn't really clear from the unit itself. The software that comes with it is called HMI Tools. Can it become more generic than that? Well, anyway, it is within the same philosophy as vBuilder, efficient and easy. But I suspect this software to be created by someone else than Velocio. It doesn't have the same flavor. More complex, more features, less visual cues of what is going on. Maybe I'm wrong. My theory is that this HMI hardware and software is some kind of OEM off-the-shelf component that you would find under a variety of brands on the market. Velocio didn't put their name on it, but they pretty much could have if they wanted to. The software supports TrueTypes fonts. That means if you'd want to use some custom fonts, you can. This may sound like something to be considered normal, but let me give you a bit of context. I used to have this Nextion thingy HMI system with my Arduino, and I must admit, it can't get any cheaper than that. Nextion offers a free HMI software with a cheap-ass hardware that just works with anything that uses a serial COM port. Great on paper, but it comes with some cons. First of all, you have to figure out the COM link with your Arduino. Sure, there is a library, but it is such a pain to use by the book. Nothing about it makes sense to me. Yes, it is doable, I guess, but it looks awful in the Arduino IDE, and for the complex animation or custom trickery I want to do, no, just no. Totally fine if you want to show a temperature sensor and have a button under it, but in my case, having to play with 10 plus screens, pop-ups that are just made of appearing and disappearing images on top of each other because pop-up is not supported. Setting fields, rapidly firing animation for smooth motions, such a hassle. The way I actually made the Arduino and the Nextion talk to each other is with strings messages. Yes, plain text serial exchange. Why not? I found this to be far easier to understand when looking at the code 6 months later than all of the codename bullcrap the Nextion library want me to use. To summarize, what I did is that when you press a button on the screen, the Nextion sends a messages like cycle start button. So the Arduino knows the startup button have been pressed. Same the other way around. The Arduino will send something along the line of this pump that pick equal 1 to notify the HMI to turn on visibility of the image name pump. If the image is not supposed to be displayed on the screen you are, then it is not, which is good, but poses new problems for the following. No state memory. That alone makes working with the Nextion a big mess. So I have this screen that contains every equipment the washer have. Pumps, valve, probes, etc. A valve, for example, can be open or closed. Well, here is the thing. First of all, the default image is the closed one. So when a valve opens, the Arduino tells this closed state image to refer to another image, the open state. But this action is not remembered. If you leave the screen and come back at it, the valve appears to be closed again. And in reality, it is not. The workaround, you guessed it, is to send continuously a refresh of all the state there is. Great way to flood the serial link, by the way. The optimized version will be to have the Nextion inform the Arduino which page is active, so that only the regarding information are sent and only once. This was one of the things my friend was working on lately, by the way. Another bothering thing about the Nextion is how it handles text. So finally, back at why I'm so happy with the new HMI I've got. You see, to overcome the fact that the Nextion don't handle TrueType fonts, and because I don't want an interface that looks like crap, like so many I see on internet, I designed every button and every text in an external image editor, exported hundreds of images for different states button, and imported them into the Nextion. And it looks good. Hell, it looks way better than anything anyone can ever make with the built-in tools of Nextion's editor. But it came at the cost of hours of harassment designing every single image that contained text. Now, no need to do that with the Velocio HMIs, and this HMI tool software even allow me to use the exact shape I used to make this button with a gradient of color absolutely perfect. It looks slick as before and demands no time to create a new button. Copy paste, edit the text, edit Modbus address, done in 10 seconds tops. When you add the fact that the Nextion doesn't support transparency, refresh images that overlap on top of each other without distinction, well, you know why you paid $70 for a 7-inch screen. You know. But don't get me wrong, I'll still recommend Nextion to anyone without much money who want to add a small screen to his Arduino project, as it is still the easiest way I found to use a touchscreen in a kinda advanced way, but be aware that it can get tricky. So in the end, I'm fairly happy with this no-name HMI. It is way closer to an actual industrial HMI with proper panel mounts provided, user login, multi-state object, TrueType fonts, alarm list, printings, logs, trend, chart, and oh, did I mention macros? If you feel limited by the built-in function, just get your C++ book out and program yourself some macro that you can call or close as you wish. I mean, for just double the price as the Nextion, you truly get double or triple amount of functionality and ease, hands down. Overall, I'm very happy to now be able to work on this project on my own, without bothering a friend or two in the process about my silly project. And I think this is a good investment as well. There is no problem to reuse those parts in the future for other projects. For smaller projects, the entry-level ACE PLC is $50. I mean, this is really close to Arduino territory here. Though, it only comes with 12 I/O at that price point. Development and debug is so easy when you can visually see your program being executed in real time. No need to post your issue in some forum hoping someone can solve it. You can just follow the path of execution to find where and why it doesn't work the way you'd expect. This really what motivates this decision in the end, not having to rely on anyone, being able to go at my own pace, and it's a pretty fast one. With Arduinos and the way I want to use them, I had been stuck so many times without being able to really understand what was going wrong. Sometimes it is because you screwed up a letter in a tag, sometimes you forget to declare a variable, sometimes you have to use a point instead of an arrow to point inside a class. And did I mention the usual way devs declare variables? I mean, if you create a class called light and then you attach an object called light with a capital L, how in hell do you expect the untrained eye like me to notice that they are two distinct things? I'm all in for the use of self-explanatory tags in programming. Everything else makes no sense to me. At this point, this is pure madness. And this situation is to be found all over the internet when I used to look for tutorials or code example. Some are well done, I must admit, don't get me wrong. Bottom line, ACE's lineup doesn't seem to be really oriented at the big industry. When you are running a billion worth of money factory 24/7, you are not going to buy the cheap plasticky unprotected I/O piece of crap. No, you pay for the peace of mind of having something that will still have available parts in 20 or 30 years and the technician that still know how to repair it. I don't see ACE product to be that at all. It's more like a dev platform that doesn't really impact your R&D cost, so all of the budget is focused on engineering the parts of the prototype. Because outside of that, this is a very capable PLC. The cycle time is within the hundreds of microseconds. ACE also has a lineup of branched PLC that can be chained together to increase the number of I/O or even distribute the CPU time across. I mean, you can do stuff with this in a small lab or an old school factory that would definitely need a bit of automation. There sure is a market here. And this market, in my opinion, also extends to DIY enthusiasts. That's it. Thanks for watching, and I'll see you on the next video.